All right, today's lesson is section 3.2, and we're going to be looking at polynomial functions of higher degree. Okay, so polynomial functions have two major characteristics to them. Okay, one, the graphs are continuous, meaning we don't have any holes in them. It's not like a piecewise function that has breaks or gaps, and that has smooth curves to it. So it can't be V-shaped like our absolute value function, no piecewise functions, no reciprocal functions, pretty much just anything that is a regular polynomial function, like with an x squared, x cubed, x to the fourth, x to the fifth, all of that type of stuff. So we're going to be looking at two specific graphs today, and if we look at them below, you can see them here. It says these are called our power functions because they both have the form. Let me grab my little, here it is. They both have this form, okay? F of x equals x to the n power, and that's what's called our power function. So when that n value is even, so we get an even value, that means my graph is going to be very similar to that of the x squared graph. Okay, and we know that the x squared graph is parabolic in shape, so it's that U-shaped graph. So if you look here, what we have graphed, my regular parent function of x squared is right there. And then the x to the fourth, whenever I get that exponent that's just a little bit higher, it's still U-shaped, but it's a little bit skinnier on the sides and a little bit flatter here at the bottom, okay? And it says if n is even, the graph of f of x equals x to the n touches the x-axis at the x-intercept, okay? When it's an odd function, the graph will be very similar to that of the x cubed function. Remember we said that was sort of the S-shaped graph, and some of you are like, I don't really see the S, but it still has that same basic shape. So I will say, and I'm going to have it down here, if this right here is my x cubed graph, that's my basic parent function of x cubed, when I have x to the fifth, what that does, it makes it a little bit flatter there at that intercept, or where we would say like that vertex point. And that's what this says. It says the greater the n value, the flatter the graph is going to be near that origin. So looking at this, we're going to sketch two graphs now. And we're just sketching them, so we don't have to make an XY chart, get specific points. We just want an idea of what is it going to look like. So we have to remember that our basic form is x minus h squared plus k. Okay, so I'm still going to be looking for that vertex point. So my vertex point is going to be negative 2, 0. And we know the shape is going to be a parabola. Okay. And because of that negative, it is going to be going down. Oh, that's a bad parabola. Okay, so we're going to go negative 2, 0. Put that there. Now, I need to look at my exponent. It's a 4, so it's going to be a little bit flatter than what a regular one would be. So what we're going to do is we're going to move that over. But we want it to be a little bit flatter. Let me try that again. There, that's a little bit better. We just want it to be a little bit flatter, okay? Remember, like I said, we're just doing a sketch because we're going to get into a little more detail in a bit. All right, so pause the video, take a moment, try the your turn, list all the things we did off to the right, and then come back and check and see if you agree. Okay, so this graph is going to be that S shape, positive cubic functions go that way. The vertex is at 3, 4. And it's just going to be a little bit flatter. So I'm going to go over 3, up 4, put my dot there. And I don't know exactly where this is going to go, but I'm going to make it a little bit flatter there. Okay, maybe that's not quite flat enough. Let me do it again. I don't know why I'm struggling with this today. There we go. That looks a little bit better. Okay. So hopefully that's what your graph is similar to. And again, we could graph it on here, and I will graph the x cubed function as well. That way we have something to compare it to. And then I'm going to do x minus 3 to the 5th power plus 4. So see how it is moved up. Let's see if I can zoom in here. My little vertex point there is moved up, and it is much more flatter there in the middle than just the regular x cubed. But we're going to try to do these without our graphing calculators. We can just use them to check our work. All right, so now it comes into, I think this is pretty fun. There's not a whole lot of math that goes into what we're going to do next. It's a leading coefficient test. You can see this whole page is just information. And then we just have one more example. So we're going to look at what that leading coefficient can tell us. So if you remember way back to elementary school, if you were the line leader, I'm sure a lot of you like to be the line leader, you were the first person in line. So you had a lot of responsibility. You had to tell that line of students where to go, how to act. If you acted goofy, they acted goofy. So the leading coefficient sort of has that same responsibility. It's going to tell the graph where it's going to go. What is it going to look like as we approach negative infinity? What is it going to look like as we approach positive infinity? So all of that we get from just the leading coefficient. So it says whether the graph of a polynomial function eventually rises or falls can be determined by the function's degree, whether it's even or odd, and the leading coefficient. So two scenarios. When n is even, okay, so n is your exponent. When the exponent is even, if the leading coefficient is positive, okay, so my exponent's even and my leading coefficient is positive, the graph will rise to the left and the right. So how I want you to remember this, because it's not very hard. When n is even, I always think of the graph of x squared. And x squared is a basic parabola. And if x squared is positive, guess what? Let me zoom in here. If little old me is here and I'm walking this way, my graph is going up. And then if I turn around and walk this way, guess what? My graph is also going up. Okay, so if my leading coefficient, so in here my leading coefficient would be 1, that's positive, it's going up in both directions. Okay, sort of like the graph they have below. Now, if my n value is still positive, so I still have my x squared, but now my leading coefficient is negative. Well, think about what your x squared graph does. Your x squared graph, that flips it upside down. So now if I'm here and I'm walking this direction, that means my graph is going down. Okay, so it's going towards negative infinity. And then if I turn around and I walk towards the right, guess what? My graph is still going down towards negative infinity. So how we write that, though, because we don't want to draw little stick figures every time. Well, you might, but that's not very mathematical. They tend to write it as what f of x does. I prefer to think about it the other way. I prefer to think, hey, and we'll just do the one we just did. If I'm going towards negative infinity, and that's what this means. This is read as x approaches. That's what that little arrow means. Negative infinity. What does my y values do, or what does my function do when my function also approaches negative infinity? And as I move towards positive infinity here, so I'm going this way, we said my graph was going down. So as I approach positive infinity, my function approaches negative infinity. Okay, same thing if it were positive. As we move this way towards negative infinity on the x-axis, what are my y values doing? Well, my y values are increasing towards positive infinity. If I'm moving to the right on the x-axis, okay, my y values are also going towards positive infinity because they're going up. So whenever you have a leading coefficient that is positive or negative and the exponent is even, it will follow these same trends, whether it's x squared, x to the 4th, x to the 6th, x to the 8th, whatever it may be. All right, so now let's think about when when n is odd. So whenever it's odd, I always think of the function, the x cubed function. We know that's sort of that S shape. So my left towards negative infinity and towards positive infinity are not going to be going the same direction this time. One's going to be going down, the other one's going to be going up because we have that sort of flip-flop. So if my leading coefficient is positive, that is the normal S-shaped graph. Okay, so as I approach positive infinity, which means I'm here and I'm walking this direction, my y values, and if you see my graph is going up this way, so that means my y values are going towards positive infinity as well. And then if I switch and I am walking this direction towards negative infinity, so I'm walking along my x-axis, okay, moving that way. If I look down, my y values or my function is going down also towards negative infinity. And then the opposite happens if the leading coefficient's negative. Because remember what we learned about our transformations, that negative out front switches the direction of my graph. So now if I'm going towards negative infinity, my graph goes up. Negative infinity, my function goes to positive infinity. When I walk towards the right, my values go down, which is negative infinity. Right, so hopefully that makes sense and you're able to relate it to what we've done so far with our transformations and parent functions. So let's do our last example. It says describe the right hand and left hand behavior of the graph of each function. Now we are going to do this without our graphing calculator. So a couple of things we look for. First of all, is this an even or odd function? It's an odd function, okay? So that means my graph is going to be S-shaped. Okay, so we have our S-shaped graph. Next, it is a negative, okay? So my n value is less than 0. That means my graph goes like this. Okay, don't care about anything else. We just know it's negative. So then we say, okay, as x approaches negative infinity. And then I'm going to say, okay, what does x do as it approaches positive infinity? And then we're going to say, okay, this is what f of x does for each. So as x approaches negative infinity, so that means on my graph we're going this way, what's my graph doing? Well, my graph, if I look, it's going up. So that means it's going to approach positive infinity. And as I walk to the right, my graph goes down, so that means that is approaching negative infinity. And that's all they want. So this right here would be our answer. Ooh, let's do some green. It is almost Christmas. Okay. So let's do 2 more. All right, the next one, it's positive. Okay, so it is an even function. Okay, it's going to be parabolic in shape. It is going up because my leading coefficient, we'll put leading coefficient equals positive 1. So then we're going to say, okay, as x approaches something, so let's do negative infinity. And then we're going to do as x approaches positive infinity. What does f of x approach? All right, so I have my little parabola here. So as I go towards negative infinity, my graph is going up. So that's positive infinity. And then as I walk to the right, my graph is going up. So again, positive infinity. And remember, if I go too fast, you can just pause these videos, slow down, get caught up. All right, last your turn. As soon as I see that x to the 5th, it's an odd function, which means it's S-shaped. My leading coefficient is positive 1, so it is that shape right there. A little bit flatter in the middle, but we just want the shape. So, as x approaches negative infinity, as x approaches positive infinity, what does f of x do? Okay, so as I'm walking to the left, my graph goes down. That's negative infinity. As I walk to the right, my graph goes up, positive infinity. All right, so again, pause the video, do these two your turns, and then come back and check to see if they're right. Okay, so the first one, you can see those answers there. Now I'm going to go to part B. Okay, we get negative infinity, and x is going to go to positive infinity. All right, so here is your practice work. It is also in today's folder. Don't forget, if you have any questions, you can send me questions on Remind, and hope you guys have a great day.